I'm continuing on with our discussion about stoichiometry that we started yesterday. Yesterday we learned what stoichiometry is, and we talked about the importance of mole ratios in order to convert between one substance and another in a balanced equation. And we were able to convert from moles of one substance to moles of another substance. Well, today we're going to continue on and learn how to convert from mass to moles in section 9.9. I'll give you a few seconds to pause your video and copy this down. The importance for this, knowing how to convert from mass to moles, is because in the chemistry lab, I don't have a balance that measures everything in moles. I have a balance that measures everything in mass. And so when I'm going into the lab and I want to make a certain amount of something, I have to know the masses. So today we're going to learn how to convert from mass to moles. And one thing that is very important is that all stoichiometric conversions between substances in a reaction must be performed in moles because the balanced equation is based on ratios of moles, not mass. And so how do I then do that if I start out with mass? So let's take a look at this. I'm using the same equation we had before. Phosphorus plus oxygen yields diphosphorus pentoxide. And my question that I have is, how many moles of P2O5 are produced by burning 1.55 kilograms of P4? So this problem has another little twist too. I have kilograms and all of my conversions have to be in grams. So let's take a look at this. So I start out with 1.55 kilograms, but one note here. First, find the molar mass of P4. We're going to be working with molar masses here. So my molar mass for P4 is 4 times the molar mass for phosphorus. I'm going back to my periodic table here, is 30.97. So 30.97 grams. And when I multiply those two numbers together, I get 123.9 grams of P4. So let's start our problem here. We start out with 1.55 kilograms of P4. Well, my molar mass is in grams, so I have to convert from kilograms to grams. I know that 1 kilogram of P4 is 1,000 grams of P4. Kilograms cancel out, so I know that I set this up properly. From there, I then know that 123.9 grams of P4, again, those cross out, is 1 mole of P4. But I'm not there yet because I want moles of P2O5. Looking at the equation, 1 mole of P4 yields 2 moles of P2O5. So when I can cancel that out, so I know I'm in the right units now. And so what I have to do is I have to multiply the top and divide by the bottom. When I do that, I end up with 25 moles of P2O5. Now, one thing I want to point out in these types of problems is right here, these problems when I'm going from mass to moles always contain a molar mass and also always contain my mole ratio. So you must always have those two things. Now this is an extra step. You're not always going to have this. A lot of times everything is in grams, but this is just one of those things that they throw in there every once in a while, so I wanted to make you aware of it. But we always have the molar mass and the mole ratio. I'm going to stop this video right here. The homework will be on another page, but just to keep these videos short, I'm going to do the next section, 9, 10, in another video.